Okay, we're working on our cylinder head design here. So I'm trying to figure out some more porting ideas here. So we've been looking at it on how your basic hair flow is going to be. And I've determined that I'm going to cut this down a little bit more on this side over here to gain some airflow. So you look down inside of the port here, you can see how it's got more of an equal trough that we're going to be putting in here, so you get more air through the head cylinder combo, and the air is going to be flowing in the correct direction because the air flows in through here. Where'd my light go? Flows in through here, makes a circle, follows the port, and shoots out this side of the valve here, not out this side like you want it to. It only flows out one side, which means all the air is on the left side of the cylinder right here, coming through this port at high velocity. Now with the red line, my original template, see how it kind of blocks the airflow a little bit because we're kind of thicker on this side than over here. Now with the new black line, you can see how I'm giving a nice equal area right across here to let the air come through. And the air is going to be high velocity over here and be very low velocity, if anything, on that side over there. So the air is going to want to be turning like this. It's going to be swirling counterclockwise direction, and that'll help fill the cylinder up because I have a vortex going right down the cylinder. So it'll actually make a little bit of a draw on the port, make it flow even better. So that should help it. Now when you go to put the exhaust out the exhaust, the air goes straight down, and now we got a straight ramp right like this. The air just drops down the ramp and goes right into our port like this. Flows right into here. Because it's going to go right through this direction like this, coming through here. Our intake, it's going this way. And it's not going to make this turn here. All the air is coming in like this, goes around the corner, shoots this direction. So if you cut this back right through here, like we did, that'll give a place for the air to go through. Yet we're still keeping the compression pretty high, which we want to do to make it burn better. So I'm going to cut it to the red line first, throw it back up in here, see what I think about it. Then I'll cut it to the black line. And I'll have to remake my template to match. What did I do with our template? Oh, template's right here. So I'll have to recut this line. You can see I kind of hand drew it a little bit right through here, what I was trying to do. Because we're looking at our tangent lines coming across our ports here. To here, to your cylinder. So there's your tangent line. So cutting anything more this way is not going to help you. Cutting more this way helps you. So we got these little titties right here we got to flow around. Over here I'm going to leave it sharp edge because I don't think it's going to be able to flow over there. So that's what we're going to do. Okay, so we're looking at what we did here. So I don't really have a cutter that I can get into here in this corner right here where my thumb is to blend it. I tried to, but all I did is just cut past my line a little bit, which is not going to help the head over here any. It looks like I did not get on the seat right here, but I got right next to the seat. I was on a top angle right there. The gray line right there is the seat. Still looks like it's there. I nicked it right there too. The intake is right on top of it. That's why I can't shorten it on this side of our ledge. So there's your cross section right there. You're grinding this out here, but you can't cut this side. So it's kind of tricky. This here we just got a nice flow up the top and it's flat. This one here I floated up a little bit, try to make a little curve to it. We're trying to make a curve like this, like going over a dune or something. But we're not relieving it down deeper. Trying to avoid that. So I'm going to go in here and do some porting in here, clean this stuff up later. But anyway, that was that. And this is our head right here. Once again, we're trying to blend it down deep. Make nice transitional curves and stuff. Here's that straight line I was trying to cut. I'm actually kind of slightly bowed like that, but close enough. And relieve it through here. So you can see where the cutter was kind of dancing across the surface here a little bit a couple times. I don't know how that nick happened there. These I did. I don't know how that. I think you did that one. Snuck in there when I wasn't looking. So you're trying to make all these surfaces here flat coming through here so the air will bleed through here. So the air comes through this side right here. follows the edge of this port, starts to turn, and just comes right across this surface. That's why I'm not too concerned about over here. It's coming up this way. That's why we got this. That would be coming through this way, going this way. That's why we're cutting more on this side and not here. If you cut it even like this, you're just going to have a big vacuum back here where the air is not going to be. All the air is coming around this way. That's why we're putting such a big valve in the motor, because it's only going to flow out of that much of the valve anyway. There's no way it's flowing around the whole head. It's going to flow right around this corner. So we're trying to make this corner have some nice flow to it. The exhaust, on the other hand, is being pushed by the air from the piston going straight into the chamber. So it has basically a flat shelf. It goes right into this port. That's why I was kind of spending a lot of time over here trying to eliminate that back cut right there. So anyway, that's what we're trying to do. So I'm going to see what it looks like. There you go. Alright, where's our gasket? So we're going to check it with and without the valves in it. Stiff back to the grinding. I'm rotating it this way. So there's what we got right now. So I still think it could probably gain by cutting out a little extra in there. Be worth quite a bit maybe. It's definitely got some flow through it. So that's why I'm not trying to radius that back corner, because you can see how it comes at 9 degrees across the cylinder face there. There's no way it's going to turn and make the curve. This one over here, same deal. Now, can you see in the hole? So you can see the flow right into the hole there.
Oh yeah. Yeah. Right where that's cut away, yeah.
And so what we're trying to do is not have any overlaps in there. So you go from the metal to the aluminum. It's nice even steps. This one you're not going to be able to see too much, but you can see the step between the aluminum and steel. And you can see the crossover channel in there. Get the focus in there. So you can see how it flows around the corner, comes across, catches that little edge right in there. It's still in there, which tries to keep from flowing in the exhaust pocket. There you go. So you don't need no flow bench to do common sense things. Air's like water, it wants to go straight. Or like you running down the street. You don't like to turn either.
I don't run down the street.
I try not to run anywhere.
Yeah.
That's why I have a motorcycle.
Yeah.
Alright, so now we're going to put our valves in here. You can see how it looks with the valves now. So once this valve starts to open, you can see how it can flow. And as it opens up more, it can flow more. As it gets way full open, which is about up here, that's probably full. You can see how it's going to flow pretty good around that one side. This one pretty much just dumps right into it. So I got this scooped out like that. It kind of funnels it right in. You see how that duplicates the curve a little bit also. So the air just kind of follows the same cross section straight into the valve. This here is adding like a guide trying to shove the air into there. And on this one's, as the air hits this edge right here, it tries to keep it from going over here. because this is going to cause turbulence. Now, if I cut this all the way back to the edge of the cylinder, I don't know if that'll hurt or help. I don't think it's going to turn 100% of the air. I think it's going to have some spillover. So the spillover's got a place to go. If you put this right there, the spillover's going to hit this wall. So I think having that's going to help us a little bit. Now I could have left this a little bit thicker through here. I could have probably gained about 30 thou right in there if I wanted. No, I didn't grind so deep. I just kind of followed the angle, but I could probably cheated and brought that up a little bit. That would have helped slightly. But all of this stuff is just guessing. Until you put it on the track and run it down the track, you don't know what it does. Flow benches and dynos are great for giving nice numbers that don't mean nothing. Only time slips count. All these computer guys don't understand it either. Now they got CF programs. Real world is still real world. Okay, so now we got the valve in the way in there. And we have about that much clearance. That's about where it's going to sit, wide open, not there, be about there. And this one over here, close the exhaust valve. There we go. See, it's only on overlap, it's only open that far, it didn't even hit it. See, I'm coming down about this far, that's our overlap. Can't even see the valve and overlap, so the valve is out of out of the way on overlap. See, this one goes like that. It'll sit about right there. Alright, so that's what that all looks like. So we just got to figure out if we want to cut this away the rest of the way. So before we do any more cutting, we're going to do a half-ass compression test to figure out what the hell we got. If we got a lot of metal cut out, we cut out a lot of areas. If we got very little metal cut out, we stay pretty conservative what we're going to cut. I definitely think cutting this way is going to make more power. So if we're already at 6-to-1 compression, I'll probably still cut it. If we're at 8-to-1, we're definitely going to cut it. And we might even cut further down to here to gain even more of the effect of what we're trying to do. If we're about 7.5-to-1 after this is cut, which means we're about 8 right now, 7 3/4 right now, then I'd say we'll just cut to that line. It's just a matter of what the compression comes in at. Now it looks like this one only got this little speck right here, did not get welded. The other head's going to have a big trough along the whole bottom that's not going to be welded. So it'll be a little bit lower because of that. But overall, it's not too bad. That spark plug disappeared we had, didn't we? So I don't think we have any problem with that spark plug sticking inside the chamber enough to be a problem. On my race bike, the plug actually is raised up so it's right up at flush with the valve. It actually sticks up slightly above. So the valve gets really close to it. This motor should be a lot further away. Alright, so next thing we got to do now is do a compression test, or a CC this up, and get some kind of an idea where we're going to be on compression. So that's our next test. Alright.